Now we're going to explore two properties of exponents, which are zero exponents and negative exponents. The zero exponent rule is pretty simple. Anything to the exponent zero is 1. I always get people who, well, maybe it's only me who asks, but I always think, why is it 1? Well, the reason why is if I ask you to simplify 3 to the 2 divided by 3 to the 2, you could think of this as 9 divided by 9, which is 1. But if I was to use my exponent laws, when dividing powers of the same base, you subtract the exponents, you would end up with 3 to the 0. So since we already know that this is something divided by itself, which is 1, we know that anytime you subtract the exponents, it means that you are dividing something by itself, which means that anything to the exponent 0 is 1. So if I ask you to evaluate 29 to the 0, you'd say 1. If I ask you to evaluate negative 29 to the 0, you'd say 1. But if I asked you to evaluate negative 29 to the 0, only the 29 is attached to the exponent 0. So this answer would actually be negative 1. So just be careful with those ones. And then negative exponents are kind of the bigger deal. Negative exponents I always think of as being in the wrong place. So if you have a to the negative n, it should have been 1 over a to the n. There's a deficit of n a's in the numerator, so it should have been dividing is kind of a way, or if it was dividing, then it should have been multiplying. So my definition of a negative exponent is that you have a deficit where you are, so you should have been in the other place. The reason why is back to that example that I showed with the quotient rule. So with the quotient rule, they taught you that when dividing powers of the same base, you can subtract the exponents. So 2 minus 5 would give you x to the negative 3. Well, why did I get a negative exponent this time? Well, because if I was to draw this out, x squared is x times x, and x to the 5 is x times x times x times x times x. Those two x's are still canceling out, but there was more x's in your denominator. So there is actually more x's in my denominator there were in my numerator. So I have a deficit of 3 in the numerator because they should have been dividing, right? They should have been in that denominator. So the rule is that if you have a negative exponent, you're in the wrong place. So if you're negative, go to the bottom. If you're negative on the bottom, go to the top. So let's just practice that skill. So for these, it's just write each expression with only positive exponents. So if I ask you to evaluate 2 to the negative 3, I can't, without a calculator, evaluate anything with a negative exponent. So I always want to make it positive first. So 2 to the negative 3, I could write as 1 over 2 to the 3. There was a deficit of 3 2's in the numerator, which means there was 3 2's in the denominator. I don't know, that wording works for me. Maybe you're just sitting there going, why is she talking about deficits? But just trust me, you're in the wrong place. So if I wanted to go further, I was going to put an equal sign below, but I will say that your textbook also says or, right? Now I can evaluate this as 1 over 2 times 2 times 2, or 1 over 8. Okay, if you wanted to check that in your calculator, it's not that you can't evaluate negative exponents, but if I plug in 2 to the exponent negative 3, I get 0.125, which is the same as 1 divided by 8. So we never want to answer with decimals. I shouldn't say never. We often don't want to answer with decimals. So this is just a nice way of writing the answer in exact form with no decimals. All right, what if I had 1 over 2 to the negative 2? Well, it's a negative exponent in the bottom, meaning it should have been in the top. So I just flip its place, and then I can, again, I should put the equal sign below, I'll just say or 4, right? So as soon as I have that positive exponent, I can evaluate it. If you have something like this, where you have a fraction with a negative exponent in the top and a negative exponent in the bottom, just move them both. The 3 squared will come to the top, the 2 cubed will go to the bottom, or you could evaluate this as 3 squared is 9 over 2 cubed is 8. Awesome. All right, last 6 here. This is just putting negative exponents in different places and seeing if you know how to deal with it. There's a reason I've asked this question and this question. What is the difference between these two questions? Hopefully you're looking at this and thinking that this one has brackets and this one doesn't. What does that mean? Well, for this one, that negative exponent is only on the z, whereas for this one, the negative exponent is on the entire bracket. So if I was to make this negative exponent positive, the 5 would stay where it is. It doesn't have a negative exponent, and just the z squared would come down to the denominator. Whereas something like this one, the negative exponent is on everything, so the whole thing would go to the denominator and get a positive exponent. And again, this one is done as far as it can, but this one, the textbook will also say or, because now you're squaring 5 and z. So 5 times 5 is 25, and z times z is z squared. So either of those are perfectly fine answers for the back of the book. So at this point here, we're just checking to make sure that you know what the negative exponent is applying to, but if you want to also evaluate, that's great. All right, this one here, what I look for is there anything that shouldn't move? So this z is to a positive exponent 1, so it's not going anywhere. Whereas the x has a negative exponent, so it should go to the bottom. And the y has a negative exponent, so it should come to the top. And if you like that one, feel free to write it. If it bothers you because you know that it should be hidden, just get rid of it. Okay, but that would be my final answer for that one, written with positive exponents. All right, what about these next two? So this could be a chance to pause your video. I asked these two questions. Now I'm asking these two questions. Can you give me the final answer with positive exponents only? Pause the video, give it a go. So for this one, the negative exponent is only on the x, so the negative 2 is going to stay on top, and then the x squared is going to go to the bottom. A lot of people get confused when something's negative. All of a sudden they just want to start moving everything. It has to be a negative exponent for it to move. You could also answer this one with the negative out front, right? It's just a negative answer. It has nothing to do with where the 2 goes. This one, the whole thing is going to go to the denominator. It's going to be negative 2x squared. Or you could actually evaluate this and do negative 2 times negative 2 is 4, and then x times x is x squared. And then last question here. I threw this one in just last minute because I wanted you to recognize that if there's a plus sign, they are each their own individual little fraction. So for example, 3 to the negative 1 would be a third. And then 4 to the negative 1 would be a fourth. They can't go both in the same denominator because they're separated terms. Whereas all of these questions that we ask, like especially this one, they're all within one term. So I'm allowed to just move things around. Sometimes if you're unsure, I think the textbook shows it, where they make like fractions within fractions like this, and then you can see that you can move things around. I find this way too confusing of a step, and so I just go straight to knowing that I can move them. But if this question had had a, let's say, a plus sign in it, then I wouldn't be allowed to do this, right? I would have to do this. So just be careful. With plus and minus signs. That's sort of the thing, is that if there's a plus and minus sign, they kind of ruin all the fun. They don't let you just move things all around because it's changing your bed mass. You have to do that order first. So for this one, because of that plus sign, they're two separate fractions, which I think the textbook even goes a further step to be like, let's add them. So they create common denominators. So I would have a common denominator of 12, and I'd be adding 4 plus 3, which would give me 7/12. I'm not going to test this so much, but I'm really just testing this idea, is that plus signs make them separate fractions, okay, more than anything else with that question. All right, so go and practice that, and then we'll move on to combining some of the skills.